Welcome everyone to today's webcast on next generation network monitoring with CA Spectrum. Before I turn the call over to Nagesh, I just want you all to hold your questions till the end of the call, and then they can be asked in the Q&A box or over the phone. And Nagesh, you can take it over now.
Okay, thank you, Catherine. Are you able to hear me?
Yes, I can hear you.
Okay, thank you. Hello, everyone, and welcome to this community webcast. In next 30 to 40 minutes, we'll talk about that how can you, leverage Spectrum, which is an existing investment for network monitoring, to extend the same for next generation network monitoring, which is nothing but your software-defined networks. So this is a brief agenda which we'll go through in next 30 to 40 minutes. Now, we have started investing into Spectrum from past 1 year or so now. And during my journey with this was I spoke to a lot of professionals during this tenure. And then there are a few people who are subject matter experts in this area. There are a few people who are catching up with the technology, and there are a few who are only aware of the jargons and the acronyms of this software-defined network. So what I thought was it will be worthwhile if I put a couple of slides that know how the network has been evolved from then to now, and then why it is important for your organization to invest in SDN, and then finally what value the Spectrum provides in terms of monitoring your SDN networks. So yeah, so we'll quickly go through that network evolution part, see the value proposition what CA Spectrum brings, and then go through the overview of some of the features, and then finally I'll talk about specific use cases and how they are benefiting the existing customers who are adopting or testing the solution with Spectrum. And then finally, we'll go through the roadmap that know what lies in the future. So starting with the evolution of the network, this is how your classical data center infrastructure network would look like. So starting from the top, you would have enterprise core. And depending on the enterprise, you will have a DC core, aggregator, access. And then from where your resources or your VMs and your hosts are connected to this network, and depending on the bandwidth requirement, you may or may not have a fabric extender in between. Coming to service chain, which are nothing but your firewalls, your load balancers, your IP intrusion systems, which lies at the DC core, where you can we can control the traffic, what goes into firewall, what not goes into firewall. And then lastly, if you are a service provider or if you're a large enterprise and you want to segregate your networks, then at the upper layer, you will have segregated network through VRF. And at the layer 2, you would have configured VLANs to segregate your network and access to your customers and to the users. So what is the limitation of this traditional data center network, and why is it important to move to the next generation network? First and foremost is the segmentation part. Segmentation is primarily based on VLANs and IP subnets, and this results into lack of mobility with this. Second is the scale part, which only allows you today with the traditional network to scale up to only 4K VLANs today, and it's difficult to build a scalable and multi-tenant environment with this kind of scale. Next is the slow deployment. In the classical data center, if you want to provision new services, new VMs, or new resources for anything, then it has to start from involving your network designers, choose the design, choose the deployment, and then finally figure out a downtime, go through a change request process, and then deploy and provision your services for your customers and users. Lastly is about the elasticity. So for example, if you have a requirement, so to give an example, if you're a retailer and a holiday season is coming up, and you want to expand your resources for that holiday season, you invest in your firewalls, you invest in your resources and other things to meet up the requirement for that holiday season. But as soon as that is gone, you cannot roll back, or it's very difficult to roll back because you have already invested in that. So that kind of elasticity to quickly provision and deprovision services was lacking into that classical data center infrastructure over there. And that is where your software-defined data center comes into picture, which gives you a solution for all these issues. First and foremost, it solves the scale problem. Now it has a concept of VXLAN, which allows you to have 16 million VXLANs, so that can scale to a very good level. And it's a concept of encapsulating packets if you want to send from one point to another point over there. Lastly, the elasticity part, which we talked about double slides, so you can quickly provision and do provision the services as per needs, and that too with minimal manual intervention. So all this benefits of elasticity, speed of deployment, flexibility, boils down to all those things where you can quickly deploy and undeploy the services as per your needs, and you can divert the resources to some other things which you are required over there, and that too with minimum manual intervention and all those things over there. And obviously, it has a lot of automation and APIs, which gives you an ability to derive your workflows from there. So these are the benefits of your software-defined data center, and that's where you should expand your existing traditional data center infrastructure to the software-defined data center. This visualization shows that how complex is to troubleshoot an application in an SDX environment today. So an application transaction through SDN stack can get very complex. And then an extended visibility would require more than your basic monitoring, which your today traditional tools will not give you. So if you want to troubleshoot a bottleneck or an outage in a complex next-gen network like this, you face challenges like you don't have visibility how your physical and your virtual networks are interconnected and what's the dependency on each other. You are unable to trace the performance issue in that highly complex layered stack. Complexity into the service chains and then the performance issues and the bottlenecks. And obviously, with all these things, it becomes very difficult to pinpoint, to find out the root cause, and which results into very slow MTTR. And this is where the service chain layer is more important for you, because it's non-SNMP. It cannot be monitored by your traditional tools over there, and all your network function chains cannot be monitored by SNMP. These money-making network functions are very important in terms of communication service providers and the enterprises. VMs also may not have SNMP agents either. So there is no way to probe or expose all the layers or the stack and perform sort of analytics to give you, a good user experience for your customers over there. And that is where our solutions help you to answer all that questions that how do I keep track of all these issues? How do I keep track of the dependencies and relationships? How do I get visibility on all these things? And this is where our solution gives you extended visibility and retains and regains your confidence into your operations over there. So what our solution will be able to provide you is to give you an extended visibility into mapping of your physical and virtual infrastructure, accurate identification of the issues, and then removing the complexities when it comes to performance and then in the layered stack over there, which will give you a quick root cause, and you will be able to pinpoint where the issue is there, and hence give you an ability to faster triage your issues and reduce your MTTR over there. So whatever we are talking about this slide, this extension into the next slide, which we had talked about, which means giving you more visibility that how your inventory looks like, how they are connected, what is physical, what is virtual, what are the relationships in between them, dynamic inventory update, and this is more important, and I'll talk in a while that how that is important, why that is important, and what was the scenario earlier and what is the scenario now, and how this dynamic inventory capability into Spectrum helps your network engineers to diagnose those issues. Obviously, root cause, that is the bread and butter of Spectrum to reduce your MTTR. and then also provide you visibility into service chain. So this is all the value of Spectrum, that with the single console, with the same Spectrum which you are using to monitor your traditional network, can now be extended to monitor your logical networks, your virtual networks, your service chain, your L4, L7 services over there. It will give you visibility. It will give you how they are connected to your physical infrastructure, and obviously help you to reduce your MTTR by pinpointing the root cause over there. And obviously the dynamic inventory update, I keep calling that in all of my slides, and I'll tell you why as I soon move to my use cases and customer scenarios. Okay, so let's take an overview that what sort of capabilities Spectrum have today. So you all know that Spectrum is very well capable, and we are kind of leaders in monitoring the physical infrastructure today. And the same can be extended to your software-defined network, so you can discover today your ACI fabric, your Nexus switches. You can monitor the connectivity between your physical Nexus switches, and then what is the relationship or the connectivity between your virtual entities. Dynamic inventory updates as soon as you provision something from your SDN controller, and obviously give you visibility into your service chain of how your network function look like. So how does it work? I mean, SNMP, even Spectrum is a traditional network monitoring tool. Then how come we are able to extend Spectrum to monitor your next generation network as well? And as you can see in this diagram, we brought into picture CA virtual network assurance, which kinds of act as a gateway for us. We also call that as an SDN gateway for Spectrum, which help us to bridge the gap between that visibility which you require to have more access to your network and to more control your network over there. So the way it works, Spectrum will go and discover your physical entities like your leaf and spine switches, your ACI fabrics, discover those entities, model those into Spectrum. Then comes into picture VNA, which goes and talks to the controller. In this case, it would be Epic. In some cases, it could be OpenStack controllers.
The system has detected that a minimum number of lines are connected to this conference. Do you want to continue your meeting? Press 1 to confirm. If there is no response, the conference will end.
Catherine, we are good to continue, right?
Yes, you're good to continue.
Okay. Yeah. This is where VNA comes into picture. It will talk to the controller. It will get your underlying inventory like your VNFs, your virtual machines, the relationship between those elements, your virtual networks and routers over there. Get the relationship status, get the performance status, normalize that data and feed into Spectrum. And then what Spectrum does, it stitches all the data from physical and virtual and gives you a complete end-to-end view that how your physical and virtual network infrastructure are interconnected to each other. And this is how the overall picture looks like when it comes to how Spectrum is extending its capability to discover your SDN network. A typical workflow is you go and configure the SDN gateway into Spectrum, and your VNA, which is our SDN gateway in our case, talks to the controller, gets all this information, normalizes that data in form of unified data model, and then Spectrum talks to this VNA client API and pushes its inventory and all other information to Spectrum, where you can see everything into Spectrum in terms of topology view, service function view, and then other updates and information in various OneClick views. So coming to all kind of views you have to leverage your monitoring capabilities, and starting with is the new SDN manager in the Explorer tab, where you can view all the related inventory of SDN in a hierarchical format. And this is where it's very helpful for a network engineer to view that which tenant is being provisioned, what kind of services are being provisioned, what does the service function chain look like, what kind of resources are being provisioned to the new tenants, and that's what that information is very helpful for them. And I'll talk you in I'll just walk you through in a while that why this is important. Second is the traditional one-click views, which you have to see your physical infrastructure topology. So you can view your ACI fabric, you can view the connections of your leaf and spine networks. Now this is something which we have introduced new into Spectrum. Those are the logical views. Apart from your physical infrastructure, you have your virtual infrastructure like your endpoint groups, which are like your virtual networks, and then you have logical constructs called as application network profile, which and contracts, which are nothing but the policies. A contract is nothing but a policy to define that what kind of packets or what kind of data will flow from one endpoint to another endpoint, or to simplify it, that what kind of data will flow from one network to another, and that's where the contract defines that kind of flow. Application network profile is nothing but the policy which defines the configuration, that know how your new services will be configured, what kind of network configuration it will be there, what kind of firewalls policies, and what kind of load balancer policies will be there. So all these elements are also being discovered by VNA and brought into Spectrum and stitched into the information in such a way that you can see that what kind of networks are tied to which contracts, what kind of services are tied to which kind of application network profiles. So you can view that all information in a single view in the topology, and gives you a visibility that know what kind of your networks are configured in what policies, and which is again very helpful and handy, because it could scale to hundreds and thousands of policies and networks when it comes to software-defined network over there. Lastly, the service function view. So we have a spotlight view to give you visibility into how your service function chain looks like, what kind of physical resources are being utilized for that service function chain, what kind of virtual resources or the virtual overlays are utilized, and finally, how does your service function view looks like, and also give you the information about the flow, whether the flow is unidirectional, bidirectional, and then from which VMs and VNFs that flow is going on. Again, a very helpful view for your network engineers over there. So now I'll go through the personas and use cases. What I wanted to do is also wanted to give you a sort of overview or a demo in a lab which I have, but I'll quickly go through the slides first, and then jump on to my one-click console to walk you through the various views. So to explain a use case, I usually do this. I'll take an example of an organization, talk about a persona. In this case, we have a bank, and our persona, which is an org engineer, is Tom, and his responsibility is obviously to check whether the infrastructure is available and there is no customer experience issue because of unavailability of any of the infrastructure over there. The first and foremost is your SDN inventory and service chain validation. And let me give you, instead of walking through this slide, let me tell you what we were talking about in the previous slides. So remember, we talked about the traditional data center network, where if you wanted to do a deployment, if you want to plan for services to be deployed for your customers and users, you have to bring into the network engineers, you have to bring the designers, you have to plan that deployment, you have to schedule that deployment, and then obviously submit a change request, and then have a downtime provision so that you can deploy your new services, your apps, and your servers and VMs and everything. But now all this complexity is gone. Everything is now policy-based. All those network design elements are taken care at the start. And whenever the new services or apps or VMs are deployed, the network engineers are not consulted at all. So the provisioning team is different. At times, it's a self-service portal where no users are given an option that what kind of services they are, and they're happening automatically. So network engineers are never ever consulted in an SDN world whether what kind of services are deployed and what kind of resources have been provisioned to them. And this is where this feature is very key and important for network engineers, because now they have an ability, okay, a new tenant has been deployed, let me go and check what kind of resources, what kind of VMs, what kind of networks, what is the service chain looks like, and all those things are very important to look to him. So this is where it's very important for the network engineers of the SDN world, and this is where this feature is very handy and sort of cool, because now they are aware of new tenants and new services deployed, and they can go and view those into service in the OneClick views into Spectrum. Second is the underlay and overlay correlation, where we obviously wanted to expand the bread and butter which Spectrum gives you today in terms of your traditional network monitoring. And as I mentioned in the above slides, our main motto is to solve your MTTR issue, so that in less time you can able to pinpoint what is the bottleneck, what is the issue, what is the root cause over there. And this underlay and overlay correlation will exactly give you that end-to-end view. And then when you have that end-to-end view, Spectrum can do its magic, perform the root cause, perform the correlation, ability to tell you that what's wrong and what is the impact because of that. And I'll show you in a while when I open my OneClick and go through those views for you. So these were the two primary use cases which I wanted to bring into the picture and give you the importance that it's very important in an SDN world that you have that kind of visibility and ability to pinpoint the root cause. Now let me go through and talk about some customer success stories or customer use cases, that how they are using Spectrum today. Starting, and I took an example from each and every customer segment. So to give an example first, a very large enterprise in Europe, they develop an application, and they provision or they give that application as a software as a service to their customers. They have the cloud deployments across the globe, and then they have their provisioning teams who will deploy those services for their customers. They use Cisco ACI for that purpose, where they wanted to deploy new services and provision new services for their customers. They also use this ACI, Cisco ACI, for provisioning inventories for their internal teams. So I went into that organization, and they walked me through that self-service portal. If you want to deploy any services, if you want to ask for resources or VMs, just go and fill into a form and then just hit button, and it goes and deploys, provisions those VMs and servers for them, and then you get all those things over there. So now imagine in that case, again, I was explaining that network engineers or your NOC engineers are not consulted for this deployment or for this provisioning. And that is where this enterprise sees that dynamic inventory update as very handy in Spectrum, and they see that very useful because they now know what kind of services, what kind of tenants, or what kind of resources are being deployed for each tenant and for each of the services that are being provisioned. The second example I want to give of an MSP in Netherlands. They own 70% of healthcare in that country, and they have decided to go to use Cisco ACI for all their customers. And today they have around like 15 customers, and by end of this fiscal year, the size is about almost getting doubled over there, and they will be using Spectrum and VNA combination to serve their customers. The way they work is they go into the customer network, they configure Cisco ACI, they configure the networks and the infrastructure, then they come out, sit into their NOC rooms, and then monitor those networks and the infrastructure. And again, the same thing happens with them also. If the customer is provisioning anything, they are not aware, but they are fully responsible and accountable for the availability of the network and infrastructure. And that is where they found Spectrum very helpful in that way. And obviously, they are also looking for most of the features like the multi-tenancy aspect over there, so that they can segregate their customer networks and provide the views into the OneClick, which we are currently working on, and I'll talk about that in my roadmap slide. Second is about the last example is about the energy and gas company. This is an example of an organization in Ireland and UK, and their network teams found ACI to be very helpful to provision VMs and servers without bothering about network into picture. And they find Spectrum very helpful in terms of monitoring their ACI fabrics and their Nexus switches over there, and they're using successfully a Spectrum to monitor that ACI fabric. So just to give you an example that how Spectrum is being used today in the various organizations, I understand that some of you guys are still testing these features, so I just wanted to highlight that some of those customer success stories and their way or style of monitoring their SDN network through Spectrum. Before going to the roadmap, I'll now take the control and go through my lab environment. So we talked about the underlay and overlay correlation. Since my screen is open about the second use case, let me talk about that. So this is the view which you will get, and you see here you have a physical switch, which is a Cisco switch over here, which is connected to your compute resource, which is a hypervisor, and within that hypervisor there's a connected virtual switch, and where you have your various VMs, which also kind of act like a VNF over there, and are being used to deploy for various services for your customers and users over there. Now, obviously, the physical part is where Spectrum is strong enough and takes care of it. This is the virtual part which VNA comes into picture and gets all the information for you, and then Spectrum stitches all the information and gives you a single view that how your physical and your virtual inventory looks like, what kind of dependency is there, and as you can see, my screen is flipping over there, that if there is any issue with any of this inventory or of any of this entity over there, then pinpointing the root cause and giving you the impact that what all could be affected, what could all be impacted over there. And that helps you to reduce your bottlenecks, to reduce your MTTR in triaging issues over there. A very powerful utility when it comes to Spectrum, and same can be extended for your software-defined networks over there. The second thing and the first use case which I mentioned was about the dynamic inventory part. And in the Explorer view, we now have something called as SDN Manager. And within the SDN Manager, now you can view all your information into a hierarchical form, that what kind of compute storage are there, what kind of fabrics are there, what kind of tenants are being deployed, what kind of services are being deployed, what kind of resources are being provisioned to that kind for those tenants. And as I told you, some of those success stories that how customers are finding this useful and meaningful, this data that to combined and into a one hierarchical form in the Explorer view, and widely used by our customers, and successfully being used to monitor that. So this was about the inventory update. Let me walk you through the service function chain. And we have a spotlight view for that. So if you want to view your service function chain, it will just pop up one other window. Now this is my test lab. Obviously, I don't have that kind of meaningful name, but you will have there. So with that, you will be able to identify, okay, if this is my service function chain, then what kind of my physical inventory is being involved, what is kind of my virtual inventory is being involved, and what kind of my service view looks like. Let me expand that view. So you can view that what kind of virtual overlay is there, what kind of virtual services are being deployed, how they're interconnected to over there, and this view, the service view, will give you what kind of network functions are being deployed and what kind of flow is there. So you can see in this example, there's a bidirectional flow between this network function chains. Again, a great visibility into your underlying infrastructure, which is not possible with your traditional network monitoring tools. With that, I come to an end of my presentation, and I'll quickly go through the roadmap slide now. So we have today inventory. We will able to give you the physical faults, and because of that you will be able to do the root cause analysis over there. But there are certain other faults which is caused by your underlying elements, and that information is only with the controller. Our plan is to extend that capability so that we can get those fault information, get those events information, provide that correlation, and give you root cause that because of that underlying faults and events, this is the impact what you will have over there. So for example, let me give you an example over there. So if you have a leaf and spine network deployed, and if you are connected to a vSphere network over there, you have a contract that the flow should be from this port to this port and should not allow any other port to flow from this network. And what happens is eventually vMotion is triggered and all your VMs are being moved to other data center over there. And that's why your port changes, and then you suddenly see issue within your EPGs that your EPG traffic is being blocked over there. And that is because you did not consider your policy to consider that vMotion into picture. So that kind of use cases, and we'll talk about more when we have that capability and those use cases. So we wanted to give more and more visibility into your underlying structure, your virtual overlays, your faults and events over there. Second thing, I talked about a customer example, and we wanted to enable a customer like that and other customers who are serving their customers on your behalf. So we want to give that MSP advantage where you will be able to segregate your virtual inventory. We'll be able to select the Spectro servers that, okay, if this is my virtual inventory or this is my VNA, then my data should go to this Spectro server. So that kind of flexibility, that kind of ability, and that kind of access and views in the OneClick, that is our motive and goal to give to our MSP customers that MSP advantage. Second is your more tighter integration with CAPM. A lot of our customers, which are of large scale, use Spectrum and CAPM in conjunction, and usually they drive their workflow by, okay, this is the fault with my physical inventory. They drill down to view more about the performance and the bottlenecks by launch in context to those physical inventories into CAPM. But today we don't have that for your virtual elements over there, and that's why we wanted to enable that integration or extend that integration so that you will not only be able to drill down into those from Spectrum, but also for those virtual entities as well. And lastly, we wanted to give you visibility into this VXLANs, that know how your VXLANs are configured, what kind of traffic over there, and likewise to have a view in Spectrum to give you more visibility into your VXLANs. So with that, I am almost with an end of my presentation. I think I was quick. I thought I'll take 40 minutes, but I was 35 minutes over there. So with that, I'll take any questions if you have.
Nagesh, there is one question in the Q&A for you from Caitlin.
Okay. I'm just reading the questions. Give me a minute. So Praveen, the capability which we talked about right now, it is available with the latest release of Spectrum and VNA. So you can grab 10.1 and latest VNA to view this all the information which we talked about right now in this presentation. And we'll be starting beta for most of the features which we talked about by like mid-September. So if you guys are interested in doing beta for ACI faults or for the multi-tenancy aspect, so just shoot an email to me, and then I'll make sure that I keep you in loop for beta testing and beta validation phases. If you have any question on the phone, then you have to press #6.
If you don't have questions now, but you have questions at later point of time, feel free to shoot an email to me or post on community. I keep watching communities as well, so hopefully we'll have your answers resolved over there.
Okay, thank you, Nagesh, for having the presentation today. And thank you, everyone, for joining.
Okay, thank you so much. Bye-bye.
Bye-bye.